I want to talk about comparison of JNI and FFM. FFM stands for Foreign Function and Memory API, which is new with Java 22. And I prepared a little project where I can compare how these two things work, JNI on the one side, and the same project with Foreign Function and Memory API. I just introduced myself already, so skip ahead. So a little background story about how this talk came to be, and then I want to tell you about JNI, just in a nutshell, how it works, and then how it works with the Foreign Function and Memory API now. And then I want to shortly compare the two things and how I personally feel about it. So the background story is that I think in 2000 and early 2000s, 2006 or so, we had a Java project for a bank, and they had a calculation core with all the banking calculations inside programmed, but this core was written in C. And since we had a Java application, we somehow had to communicate with this banking core. There was only like two alternatives: either rewrite the banking core in Java, which was not really an option, or just use it somehow written in C. And there it was JNI. We had to choose to use JNI. And yeah, since back then, almost 20 years ago, I was still part-time programming in C and C++. This was my part to connect our application to the banking core with JNI, which was not a pleasant experience, to say the least. So you have, when you use or when you want to communicate with some program written for a native or in a native language, so written for a program that runs on this machine and not like the Java that can run on any machine where a JVM is installed, you have two problems. So to call native programs, you have two problems. You have to somehow allocate memory, off-heap memory, which is not managed by the JVM, but by the machine. And you have to somehow call this native library. And these two problems we have to solve. The old way was, or in the old way, Java way still existent. You can use byte buffers to allocate native memory. Byte buffer via allocate direct and just type in the capacity you want to allocate. But then you're restricted to maximum 2 GB of memory you can allocate via this. And the deallocation is not really in your hands. Or you could use the unsafe API, which is still in Java. But as I said, it's unsafe. You can do almost anything with it. You can even allocate huge regions of memory, but then you also have to take control over the deallocation. You have maybe take care of dangling pointers or anything that comes with it. So this is, you really have to know your way around to use this. This is for the foreign memory, and for the foreign functions, you had to use JNI. And even within the JVM, JNI is used so far. I heard that with now the foreign function memory API in place, this will also change so that the JVM uses the FFM to make native calls to the machine. So JNI in a nutshell, how does it work? Maybe you have seen it already somewhere. You can declare native methods in your code, and then you have to write some C program to make this native method somehow call a native code. You have to implement this code in a separate shared library, and then the JVM will do the bridging for you once you told that I want to use this library. And this thing is inside Java since Java 1.1, so quite old already. We just learned that the first version of Java was in 1995, so maybe some 2 or 3 years later. And as I said, even Java and the JVM uses JNI, and there are classes which have native methods. And yeah, it's just a natural thing that you, for instance, the clock is running on your computer, so you want to know what time it is and so on. Things like that. And sometimes there are libraries which you want to use or need to use, which are just written in a different language, and they will not be rewritten in Java and will not become a Java library. So you have to maybe use them, and yeah. So far it was via JNI, which is not pleasant to use, and now you can use it with Foreign Function Memory API, which we'll have a look at in a minute or in a few minutes. But first, so using JNI, what would you have to do? You have your Java client, you have this native library you want to use, and so what happens? What do you have to do to implement this with JNI? Of course, as I just said, you have to declare a native method in your Java code, and then you have to generate, you can generate an header file, a Java C, a header, a C++ header file out of your Java code for this native method. Then you have to implement this with a native language, in this case C or C++, and you have to pack everything up into a library. And this implementation you write here, this is using the actual library you want to call, and it calls this library. So will be packed in a new library, and then you have to load this library into your Java code. And then fingers crossed, everything works. But the direct call from your native method to the native library without this way around here is not possible. This is not possible. And you have to leave your Java ecosystem. This is all written in C. And you as a Java developer may not have the good knowledge about C or C++. So you need to have good knowledge about this language, or maybe you have someone in your team who has this knowledge, and you need to know about the memory management in these languages, and you have to be aware of potential memory leaks because you allocate memory but never free it, this native memory, or the other way around, you want to use memory and you already freed it. Things like that, all these kind of problems, which we don't have or usually don't have in Java. So just a short example, I prepared something for you. It's called a Sudoku solver. I found it somewhere on the internet. And what you have here, this is something I want to use. I want to use the Sudoku solver, and it has a header file which says, okay, here's a structure. You give me data in the structure, and I solve the Sudoku for you. So the Sudoku is put in here in a certain way. So to use this in out of my Java um, project, what I need to do is I define a native method. In this case, I uh, put in an two-dimensional int array with the board, with the Sudoku board, so to speak, and I say, okay, solve the Sudoku, and I get the solution back. So to implement this native method, I have to call Java C minus H, and what I get is something like this. This is the header file I get. And this already looks ugly in my in my opinion. So here I have my method, my native method, and it gets some Java environment, a JNI environment input, some other object, and my input array. It doesn't say anything about double a two-dimensional array, and I get an integer array back. So I have to implement this, and therefore I created another project to implement this. This is the project and the same header file. And here comes the implementation, and make it a little smaller. Just I have to take care of all the memory management and everything. So I have to first read out the input array, somehow get the data out of there, and then I fill the structure of the original library I want to call, and then somewhere there I just say call the method here, solve the Sudoku, and then I get some int array back, and I have to convert this array back to my JNI structure, and so on, so on. It's a lot of work just for calling one method. And I have to pack everything in a library, which I did here. And this library gets loaded in my Java program. Sorry. Yep. Here. Here I say system load library. And then I can call the solve Sudoku here, and everything is hopefully fine. And I have a little test. I have some input data. This is a Sudoku I want to solve, the first one here. And fingers crossed, I run it. And Sudoku solved. Okay. So, but as you can see, I have to leave my Java ecosystem. I have to write C++ code. I have to take care of all the memory management inside there. And yeah, it's not very convenient. Very nice. It's not very nice. So how is it done now with Java 22? The foreign function memory API is part of Project Panama, and it's final since Java 22, at least the FFM part. And what you have now is some new concepts about managing a native memory. We have a concept of arenas. Arenas are kind of a wrapper around memory segments, and they take care of the life cycle of those memory segments. What memory segments are, I come to in a minute. And the arena is closable, and you can have different sorts of arenas, and this determines when it's closed and so on. And so you have a deterministic deallocation of memory segments, and you can't access those memory segments anymore if the arena where they are inside doesn't exist anymore. So you have different kinds of arenas, like global, confined, or shared. What's the difference? You can look it up. And then you have memory segments. Memory segments, in fact, can represent on-heap or off-heap memory regions. You can choose, and off-heap memory segments have to live in an arena, and therefore the life cycle of this memory segment is taken care of. So when the arena is closed, the memory segment is gone, it's freed, and no dangling pointers, no not freed memory, and so on. And then you have something like a memory layout. So it's like kind of a blueprint for the memory segment. You can say, oh, this memory segment should look in this structure. I have like a group of memory layouts, and there are some sequences inside and some values and things like that. So I can structure my the way my memory layout is assigned, and yeah, so I can say, oh, just give me a memory segment for this memory layout. And there's another concept, this is the war handles, which just help me in handling offsets inside the memory structure, memory segment. So just a small picture. So you have the arena, and inside the arena you have memory segments, and then you can have the memory layouts, and the arena just gives you some sort of method for segment allocators, and you just can say, okay, please allocate a memory segment for this memory layout or for some war handles. And put in strings or any values or any bigger structure of memory you want to allocate. And then how do you implement this all into your Java client? So first you already can load the actual library you want to talk to. So you don't have to write a second library which calls this actual library you want to talk to. And then you load this. This is all inside your Java code. And then you get yourself a so-called downcall handle for the method handle. To get a method handle, you want to call for the method you want to call inside this native library. And then you define an arena and a memory segment with the memory layout, which is kind of according to the structure you want to fill in or give to that method you want to call. And then you just say, okay, please, downcall handler, call this method, and please take this arena or this memory segment and just communicate with the native library. And that's all you have to do. And once the arena is closed, all the memory is freed, and you're on the safe side. So you stay within your Java code. I also have a small example for this. So here you load the library you want to talk to, and then I read in the board, and I have my memory layout here defined. This is the same as the structure of the method I want to call, and I get some war handles, and then I define an arena and allocate memory for the structure, and I put in all the rest of the data I have to deliver. And then I just say solve. The method is solve. I want to call, just invoke the method, and then I get an result back, and I just write it out as a result to my screen. So it's all within my Java code, but you can argue it's still a lot of code and still not too nice. So still a lot to do. Okay, I don't have to take care of some memory to free it and everything, but yeah, it's still not too nice. But then, and it works. I just run it again, or run this one, and here I have my Sudoku solved. So as I said, the code is not too nice and still quite a lot of code to write, but we have help to maybe write less code. And this help is a tool called JExtract, and you can tell JExtract which library you want to use, which native library you want to use, and it generates some Java code for you. It generates memory layouts for you and everything. And as a result, you have kind of helper classes and helper functions which you can call. And so your code will be less talkative. You just use these helper functions and helper classes, which are generated for you. You could argue, why is it not part of the foreign function memory API? This was a decision made by the developers that the tool will stay as a separate tool, at least for the time being. So I have another example where I used JExtract. What you get is this code from JExtract. I don't go into detail. It just has some helper memory, helper classes, and helper methods, and so I just need to read in the board and create an arena, get some native memory, set. I even get helper methods for setting other parameters which I need to set, and I just call the solve method, which is also part of these helper classes or helper method. And then, yeah, this is much cleaner, lot less code, and looks almost nothing very strange anymore. So it's just like simple Java code, as simple as it can get. And of course, it also works. And I get my Sudoku solved. Okay. So my subjective assessment is, okay, both approaches are still not platform independent, since you have this native library you want to call, which is different for Windows or Mac or Linux. So that's the fact. But if you have Java 22, you can use foreign function memory API. If not, you're stuck to JNI if you have to call native libraries. With FFM, you can completely stay inside your Java ecosystem. You don't have to get out of it. You maybe just have to read the header file of of the library you want to call and see how to call the methods effectively and what data they need and so on. But maybe hopefully there is some other description online somewhere. And you don't have to define any native methods anymore. And I think you have less code as with JNI, and if not less, but nicer code as with JNI, and especially if you use JExtract. The concepts of memory segments and arenas and memory layouts and such, there need some getting used to, but I always say I did it, so you can do it as well. No problem with that. And you don't have to fear any memory leaks or anything, program crashes due to memory leaks or use after freed and something like that. Okay, that's from my side. Thank you for having me. And yeah, if there are any questions, please ask.